I'd like to invite Team 1 up on stage. Focus on follow-up. Who's that? Oh, are they remote? Oh, okay. So do they begin sharing their screen? Yeah. Who's speaking for Team 1?
Nathan is.
Great. Take it away, Nathan.
All right. Just confirming you guys see my screen all right.
Yes, we can.
All right. So we've got 5 team members. We're a hybrid team this year, and we are presenting on follow-up findings. The background for this project really has to do with the ability to capture patients that had recommendations in radiology reports for follow-up. Many studies show that up to 35% of follow-up rates are not performed and patients don't get the required follow-up that's needed. That's both dangerous for the patients and potentially for the radiology practice. There's renewed interest in using the automation tools such as ChatGPT or AI or NLP models in order to find these follow-up recommendations in the reports. One of the notes from the research shows that recommendations should be clear and contain follow-up modality and time frame for follow-up adherence to be followed. The SIIM dataset didn't have any follow-up recommendations other than a few mammography reports, and so we added several lines to the SIIM dataset that'll be added for next year, and we used the FIRE tools to query the database in order to extract the follow-up findings. Team approach, we developed 2 different models. One model came from Stefan and Andre, and the other one came from Vikash. We used both regex and large language models, as well as natural language processing and keyword findings. We use regular expressions. Regular expressions are a sequence of characters that specifies a match pattern in a text. But really what they do is they search for strings and assemble a larger language out of smaller pieces. The regex that we used and that we generated are as follows. I'm going to let you read those and review those there. This is what we use to search for the modalities for the time frame and to look for the recommendation or the follow-up sections. It's a short video. I'm going to explain it as it goes. But basically, we were able to review the follow-up findings within the SIIM cases. And what would happen was when a phrase was seen that had recommendation in there, it was highlighted green. The imaging modality that it found, such as CT, that circled there, was in red, and the time frame is in 3 months. This is the data that we were searching for using the regex model. Oh, sorry, excuse me. Maybe next slide. We actually created some of the regex models using ChatGPT. This is a brief example which shows one of the lines of code that we used. So we used both NLP models such as ChatGPT and regex 101 to create these models. The advantage to using these models is the ability to formulate and detect follow-up recommendations without a lot of training. These are some of the recommendations that came through a large language model when we asked it to create a table and using some of our examples. These are some of the impressions which were reformed with recommendations. For example, if you see the bottom line here, it says very bad situation, recommend a second opinion. The ChatGPT created that when it was a recommendation for a short interval follow-up CT. It didn't know what to do with our model. So there are some limitations with this. And when you have a time frame which doesn't fit or is too short, then these are things that need further work. A few limitations. OpenAI ChatGPT does not handle PHI, and we should not be putting in patients. It's not HIPAA compliant. These are things that we definitely know are limited for this type of model for going into actual radiology reports. And so de-identification of patient information is needed. Additionally, if you were to use a model such as this, you would need an incident response team and staff training on how to use this appropriately. The second thing that we did was we used a second model with Vikash. This had NLP using keywords. This was a program developed by Vikash, which we don't have a full tutorial on now, but he has the coding for, which we use the data set, the updated data set to analyze for updates. We searched for keywords and we identified the patient name, which study was performed, and then we parsed out the impression line. Some of the keywords used for search were recommend, follow-up, and then follow-up in different types of forms and repeat imaging. And there may be others as well that we can add or update to the code. This is an example, parsed out a screenshot of what we found. For example, the first line shows that the file that it came from. So it shows the file where we got the report. The second line is the impression line in the report. So this was specifically parsed out. And the third line, it's the keyword that was found, that it said, hey, I used this word to find it. There are other examples, but this is one. This one in particular, it actually found mammography follow-up recommendations. These were not follow-up recommendations that we had inserted. These were existing ones, but I'm sure it would find some of the ones that we had inserted as well. The future impact of the follow-up recommendations is vast. I think that these models can be used to retrospectively review radiology reports. We did not tag any reports for follow-up. This was all detected using NLP and the regex. And then important notes are study time frame, and patient information. These identifiers need to be in the report, and they need to be searchable. The real goal is to provide better patient care, helping patients know that they had a follow-up recommendation, to be able to track that and automate the tracking. And it helps in a number of ways. First of all, it's potentially a additional RVUs, additional workflow to a radiology practice. And secondly, can help avoid litigation if a follow-up recommendation is needed. Thank you so much.
Thank you. Okay, now we've got 1 to 2 minutes for judge questions. Do we have any?
Jason here. So thank you for the presentation. Going directly into the meat to not waste time. A quick question. You're talking about do you have ideas about the implementation of this? You're talking about applying retrospectively. Is there any ideas of how that will be actually useful if it's done retrospectively, or do you have ideas on how to do it not retrospectively but on a continuous basis, and what would be the advantage of that, or the settings for such an implementation?
Yeah, thank you so much for the question. So we can definitely use tools such as like Nuance's Empower to go back through and search all radiology reports in a time frame. The real goal would be to do that, to find patients that have already had follow-up, and not to really burden the radiologist so much as to like put a special code or identifier in that it needs follow-up. That might be helpful, but to be able to go in and say, hey, this patient had a CT scan 3 months ago or 6 months ago, and it was never followed up, and we need to send a letter to them or notify the primary care or ordering provider that this needs to happen. So that would be the end goal and end product. This project didn't reach that far yet.
All right. Thank you so much, Team 1.